All right, we're still working in Module 4, Lesson 6 on solving our solutions to a linear equation. So we're going to use the same step for solving that we've been doing. Simplify each side of the equal sign, gather all your x terms up on one side. So let's look at another example. Looking at this, I know it can look long and confusing. That's why I always like to make everything addition. It's not a necessity, but you need to recognize if you don't. Like this minus actually means you're minusing everything in parentheses. And so if I change that to addition, it usually makes it a little bit easier to see. So let's try. So if I have 7x, instead of saying minus, I'm going to say plus a negative. How do we deal with that? Well, negative what? Negative this whole thing, or like remember what I was doing before? I was putting a -1 there. We're going to end up using the distributive property. You can either think of it as distributing the negative or distributing a -1 times both of those. And then instead of saying -8 here on the other side of the parentheses, I'm going to say plus a -8. All right, so there's that side. Equals, I'm going to just leave this for now, but we're definitely going to use the distributive property. It's all adding, we could have done it. Instead of saying minus 7x, I'm going to say plus a -7x plus 5. Now, I'm not, like, remember, that's not in parentheses, so that minus only goes to the 7x. Long problem, so we're going to keep cracking away at it, okay? Let's use our distributive property. So this is going to become 7x plus -1 times 3x, which will be a -3x, plus sign, and -1 times 5, which is a -5, plus -8. It's like a problem has to get longer before it gets shorter. All right, so now we're going to go half of 8x. That's 4x. And guys, one of the biggest problems I see is people do that, but they don't do this next one. Remember, we're multiplying a half by everything in parentheses. Half of 20 is 10, plus a -7x plus 5. All right. I don't know if I should start doing this before, but that's okay. Now we're working on each side of the equal sign, so let's simplify it. If I have 7x's and a -3x's, that becomes 4x's, plus -5 and -8. Those are like terms. If I add them together, I get a -13. Over here, if I have 4x's and -7x's, if I combine those, that's a -3x's. And if you can't see it just by looking at that, you can absolutely just plug that in calculator, 4 plus a -7. And then we have plus 10 and 5 are like terms. I can add those together and get 15. So you see what I mean? It's like we make the problem longer and then all of a sudden it gets a lot shorter. All right, sorry I got interrupted, so if I'm repeating something, I'm sorry. Anyway, we have to make things, like we have to like spread it out and write everything out, and then all of a sudden the problem becomes a lot shorter. And it's going to be the same thing every single time. So when we look here, we've seen this before. We have variables on both sides. I've simplified this side, I've simplified this side. Now we got to gather up all our x terms. You can go either way. I'm going to get rid of this -3x, so I'm going to combine it with a positive 3x. Again, adding and subtracting. We're not dividing yet. We're not solving for the x. We're moving the x terms. So if I add 3x to the right side, I have to add 3x to the left side. That's 7x plus a -13 equals, that's 0. That's what we wanted, x's to go away. And then we have our 15. Two-step equation. We can do this. We're solving for 7x. So guys, get through, persevere through those top 2 steps, right? Write everything out. Use the distributive property, because what's going to happen is you're going to get down here. And again, this is hopefully something you're comfortable with. So I'm solving for the x term, so I have to get rid of this -13. So I'm going to add 13 to both sides. I'm going to bring down my 7x. This canceled, equals 15 plus 13 is 28. And then now we get rid of the 7. So we're solving for the x. I'm going to divide both sides by 7. 7 divided by 7 is 1x. 28 divided by 7 is 4. And isn't that a nice little answer there? Okay, again, same processes all the way through. One more example. All right, so for this one, well, let's rewrite it. Let's keep doing what we've been doing. I'm going to rewrite this as 5 times the quantity 3x plus 4. Instead of saying -2, I'm going to say plus a -2. Again, keep, change, or subtracting is the same thing as adding its opposite. Equals 7x, instead of minus 3, I'm going to say plus a negative 3 times negative 2x plus 11. Okay, again, guys, this isn't a necessity, but if you don't recognize this as being a minus 3 here, or a negative 3, you might distribute the 3, but you're actually supposed to distribute a negative 3. Okay, now, speaking of distribute, let's do it. 5 times 3x is 15x plus 5 times 4 is 20 plus negative 2x equals 7x plus negative 3 times negative 2 is a positive 6x plus sign, negative 3 times 11 is a negative 33. All right, simplify both sides. If I have 15 x's and negative 2 x's, that's 13 x's. And then I have my plus 20 here. And that has to equal, over here on this side to simplify, if I have 7 x's and 6 x's, that's 13 x's plus a negative 33. All right, now I got to get rid of my 13 x's. Doesn't matter which one I choose to get rid of, so I'll just get rid of this one. Subtract 13x, subtract 13x. If I have 13 x's and I take away 13 x's, it's gone, left with 20 equals, if I have 13 x's and I take away 13 x's, that's gone, and I'm left with 20 equals a negative 33. Not true. 20 does not equal a negative 33. And sometimes you might think we might have made a mistake here, but there's a reason I picked this problem, and I know I didn't make a mistake in this one. 20 does not equal negative 3. So there is no value of x that will ever make this side equal to this side. So we say that there is no solution.
Oh, hey guys!
And Jack just got here, just in time. And he must have been running. All right. So there is no solution to that problem. And now I'm going to get bombarded by stuffed animals, and Abby wants to say hi.
Hi.
And they're running too. So sorry for this distraction. Jack's going to be quiet here. And I almost made it. The last thing I wanted to say is it's okay. Sometimes there is not going to be a solution. When we get something like 20 equals negative 33, it means there is no value of x we can put in here that will ever make this side equal that side. Nothing wrong with it. It's just there's no solution. So in our summary here, at the very bottom, we can say this. When an equation is transformed into an untrue sentence, such as 5 equals 11 or 20 equals negative 33, we say the equation has no solution. And that's part of those new type of solutions we're going to be getting into. Not new, but we're just going to have to understand not every equation has a solution. Follow your steps. Get to this two-step equation. And I promise the more you practice it, the easier it gets.